Very good morning to all. This is Dr. C. Rene Robin, Associate Dean of Jerusalem College of Engineering and the course instructor for software testing. So today we are going to revise the first unit, the introduction about software testing. Okay, I'm very happy to meet you all through this Google Meet. You're all in lockdown and effectively utilizing your time, spending your time with assignments, listening lectures, doing your mini projects. I'm happy about it. Okay. Let us move to the topic. So the software engineering, you're all aware of it. Software engineering is one of the phase. Software testing is one of the important phases of software engineering. Okay, software engineering consists of 7 phases. SDLC, software development life cycle. It consists of 7 phases: software requirement specification, analysis, design, coding, testing, implementation, and maintenance. Okay, so one among the 7 phases of software development life cycle is software testing. Okay, we are detailed studying about the software testing. Okay, the very first, I have divided this entire unit into 3 parts. Okay, part A, part B, and part 3 for your convenience. And then the part A, we are going to, so the first topic we are going to study is testing as an engineering activity. Okay, so when I say testing as an engineering activity, so you all remember the various phases of software development life cycle. Okay, we know the phases. We know software development process is an engineering activity, but in the same time, I want to stress here the software testing is also an engineering activity. Okay, if I want to prove that software testing is an engineering activity, so I have to identify the cyclic process. Many times I have conveyed it in the class. Say any engineering process, if you want to claim that any development process, if you want to claim it as engineering process, you are supposed to prove that it is a cyclic process. Okay, any process has this cyclic process, we call it as engineering process. Okay, so software systems are becoming more challenged to build. Okay, it is not like other products. Okay, software, making a software, okay, it is very sensitive product, so we have to be very careful. So we say it is an engineering, it is a challenging task, and the softwares are playing increasingly important role in the society. To go to the society, if you look at even our day-to-day activities, all the household things are embedded with softwares. Okay, so it is everywhere. It is there. If you go to a mall, if you go to a shopping complex, even if you go to flight, if you want to book a ticket, say everything is automized. So it is increasingly the softwares are playing vital role in the society. And the what is today's demand is we want good software developers, one who can able to develop software in a systematic way. So there is high demand for software developers, and there is a pressure for software development professional focus on quality. Okay, so quality is the most expected thing in any development. The software development is not exceptional. It is very important to have to develop a quality product. Okay, poor quality software can cause loss of life or property is no longer acceptable to the society. Okay, so because it is very sensitive, all the softwares are very sensitive. If anything, if you compromise on quality, or if you deploy or poor quality software, then we have to face a lot of calamity. So it will not be accepted by the society. So failure can result in heavy losses. Okay, we have a lot of case studies, and quality is determined by the attributes such as reliability. I have to rely my software, and correctness. Okay, it should be very accurate, and it must be used by all the end users, and the ability to meet all the requirements. We are developing a software. When you develop a software, You are not developing for yourself. You are developing your software for the end users. So you have to satisfy, or the software developer has to satisfy all the stakeholders or the end users. High qualified staff make sure that software products are built on time, within budget, and of the highest quality. Okay, you cannot say that I will take more time because I have to concentrate on quality of the software. There is no point of saying like this. High qualified staff. Okay, we need to have trained people. That is what you are doing in computer science and engineering. You are doing a lot of programming skills. You are spending a lot of time. We are encouraging you to spend a lot of time. We are encouraging you to do mini project. We are encouraging you to do projects. Okay, to enhance your coding skill. So when I say I told you know the elements of the all the engineering activities, all the consist of cyclic process. Okay, similarly, the various, if you look at various elements of engineering disciplines, it may be civil engineering, it may be mechanical engineering, it may be electrical engineering, it may be chemical engineering, it may be computer engineering. Okay, so the basic things are basic principles, process, standards, measurements, tools, methods, best practices, code of ethics, body of knowledge. So all these are there in all engineering disciplines. Okay, so all engineering fields working with some basic principles. It has its own processes to develop the product. It has its own standards. It has its own measurements, metrics. It has its own tools, methods, best practices, code of body of knowledge. Okay, so if you look at the software engineering, we have to give specific importance on testing. Okay, so many times I told you in the classroom that if you put 100% effort for developing a software, you have to put 200% effort for testing. Okay, so without the proper testing, without confirming the quality, should not deploy because it is very sensitive. All the software products are very sensitive. A small mistake, if you make small mistake, that will make a big calamity in the society. So we have to be very careful. So you have to give more importance for testing. And as a software developer, as a computer science student, we should know the importance of testing, or the role of testing in the software development environment. So using an engineering approach to software development means the following. What is the engineering approach in the software development environment? The development of the process is well understood. Projects are planned, not only project, whatever you do, you have to plan. If you don't have proper plan, then you cannot execute things in a right manner. Today, I'm handling this session from 10 o'clock to 11 o'clock. So we had a lot of planning. So department has given a proper timetable to the instructor, to me. And I have yesterday given instruction to my students. Today I have created the meeting. Today I informed through WhatsApp group. It's all coming in the planning. If I would have not planned it properly, I cannot expect more students. I cannot expect. Okay, so life cycle models are defined and adhered to. Okay, so any development process you have to adhere the life cycle models. Standards are in place for product and process. Okay, what standard you are going to adopt for your development process? Okay, so you cannot do your software on your own as you develop software in the laboratory. Okay, when as a student you can do it, but as a professional you cannot do it. You have to follow some standards. Measurements are employed to evaluate product and process quality. In order to ensure the quality of the product, we have to we have to adopt proper measurements and metrics. And the components are reused. It is not used in throw. Even the softwares, even the components you have developed, you have to develop in such a manner to reuse it for in future. So now let us see testing as a process. Okay, so software testing is a process of executing a program or application with the intent of identifying bugs. I don't have any other job. My priority on performing the testing or perform the software testing is to identify bugs. Okay, So the main objective of performing software testing is to identify errors, bugs, or defects. Testing is the process of validating a piece of software meets its business and technical requirements. Okay, so I have the software requirement specification in my left hand side, and I have developed the software in my at my right side. Okay, what I'm going to do during the testing is whether I'm meeting the requirement which has been mentioned by the client or the end user. It has been recorded at software requirement specification, whether I'm meeting it with the help of the developed software. Okay, so that process is nothing but software testing. So testing is a process rather than a single activity. This process starts from test planning, then designing test cases, preparing for execution and evaluation status till the test closure. From starting to test closure, we have to undergo lot of activities. Okay, that is nothing but it's all coming under the activities, some like that designing test cases. The core concept, the core area in software testing is designing or developing test cases. Test cases are going to play a vital role in the software development, software testing process, and preparing for execution and evaluating. Once the test cases are developed, we have to be ready to prepare the execution. We have to execute it properly with the help of the proper framework or the architecture. And once it is executed, the result of the testing must be evaluated properly, and the final stage is test closure. We will see all those things, all the terminologies thoroughly in today's session. Test planning has two major tasks. The first thing is to determine the scope and risk and identify the objective of testing. Okay, so if you want to plan, today I am taking a class. What is my plan? What is my plan? What is the scope? Scope is to revise the subject. Okay, so to determine the scope and risk involved, what are the risks involved in the testing process, and identify the objective of the testing. That is the first part of your software testing planning, software test planning. Then to determine the test approach, there are a number of approaches out there. During the planning, we are finalizing the test approach for the particular test. Then third, to implement the test policy or to test strategy. Okay, so we have what strategy we are going to adopt. Test strategy is an outline that describes the testing portion of software development lifecycle. It is created to inform project manager, testers, and developer about some key issues of the testing process. This includes testing objective, methods of testing, total time and resources required for project, and the testing environment. Okay, so we have to identify the test strategy. So in order to help the project manager and all the team members working for this project or test the project, and to determine the required test resources like people, test environment, how many computers I have, etc. So I have to plan for all the resources. Okay, how many people are there? If I want to recruit a few more people, I have to plan it before starting the execution. Okay, testing process. So it's all coming under software test planning. To schedule test analysis and test task, test implementation, execution. When you are going to do analysis, when you are going to design, when you are going to implement, what tool you are going to use, execution, when you are executing, what are the main core concept you are going to concentrate, what would be your evaluation result, how we are going to present it. Everything must be planned at the beginning. Finally, to determine exit criteria, we need to set criteria such as coverage criteria. Okay, so testing, so compromising, achieving 100% is not so easy. So we need to fix some threshold where I can stop my execution. So we have to identify how many test cases you are going to execute and when you are going to wind up your testing process. That is nothing but exit criteria. I will explain in the future slides. Test control has the following major task: to measure and analyze the results of reviewing and testing. Okay, so the test result must be reviewed. The test results must be reviewed, and to monitor this test control is to monitor, document progress, test coverage and criteria. Okay, so it is a responsibility of the test control to monitor the progress, test coverage, and exit criteria. And it provides information on testing, initiate corrective actions, and it helps us to take a proper decision making, because decision making is very important before we present our report to the higher official project manager. So we are seeing it as we are seeing these concepts under the topic engineering software testing as an engineering activity. Okay, if I want to prove that software testing is an engineering activity, I have to put all the sub process into a cyclic process. So the next thing is the analysis and design phase. Okay, so to review the test base. So test base is very important. So in general, I can say that what we have in software requirement specification, it's a document where we have all the information about the softwares, what are all the expectations of the customer. It's all recorded and documented in the form of software requirement specification. Similarly, test base is the information we need in order to start the test analysis and create our own test cases. Basically, it's a document on which test cases are based, such as requirement. It has requirements, design specification, product risk analysis, architecture interfaces. We can use this test-based document to understand what the system should do once built. Okay, it gives clear-cut idea about the software and how to proceed your testing. To identify test conditions during the analysis and design phase, then to design the test, then to evaluate testability of the requirement and system, we will design the test environment setup and identify and required infrastructure and tools. It's all, we are analyzing various tools, we are analyzing various environment, we are analyzing the architecture. Okay, so it's all finalized in the analysis and design phase. What we do in the implementation and the execution phase. During the test implementation execution, we take the test conditions into test cases and procedures and the other testwares such as scripts for automation, the test environment, and any other test infrastructure. Okay. During the implementation part, we will take the required or the developed test cases and we will execute it with the help of valid data. Sometimes if you go for automation testing, we will take the scripts, and the testware is nothing but the scripts which are used for automation testing, and the environment and other infrastructure with the help of the environment and the infrastructure which we have identified in the analysis and design phase. Test cases is a set of conditions under which a tester will determine whether the application was working correctly or not. Testware is a term for all utilities that serve in combination of testing a software like scripts, the test environment, and any other testing test infrastructure for later use. So test implementation has the following major task: to develop and prioritize our test cases by using techniques and create test data, specifically identify the test data. So for example, if you develop a software for adding two numbers, the identified here, the specified identified data is nothing but 1 plus 1. Okay, my basic test case. Okay, so identified data, I will take 1 plus 1. Then I will take other some increased digits, something like that. Okay, so test data, test cases will be executed with the help of the identified test data. We also write some instruction on carrying out test, which is known as test procedures. So when you go for automation testing, we need to have the test procedures. We may also need to automate some test using test harness and automated test scripts. So what is test harness? It's a collection of software and test data. For testing a program unit, it is a bundle, it is a framework, it is a package. And it's by running it under different conditions on monitoring its behavior and output. Okay, it's a package, it's a framework. It consists of the required softwares, testwares, and the various data we are going to consider for this. To create test suites from the test cases for efficient test cases, test suites is a collection of test cases, okay, that are used to test a software program to show that it has some specified set of behaviors. Okay, then test suites often contains detailed instruction and information on each collection of test cases on the system configuration to be used during testing. Test suites are used to group similar test cases together. Okay, for a particular software, I can generate n number of. Okay, there is no limitation for the testers to generate in the generation of test cases. Okay, so keeping this in mind, you cannot spend your entire time for developing test cases. Okay, you have to plan accordingly, and once this test cases are generated, you have to group it. Okay, we have to cluster it. Okay, so and put it into different test suites. Okay, when you say that I have a number of test cases in the particular test suites, it has some similarity. Okay, similarly, you have to cluster it and you can put it into a test suites. Test execution is the following major task: to execute test suites and individual test cases, following the test cases procedure to re-execute the test that previously failed in order to confirm a fix. This is known as confirmation testing or retesting. Okay, you cannot throw the failed test cases. Sometimes it fails, and after sometimes it may, after making some modification over the software which you have developed, the test cases which failed in the previous execution may succeed in the next. So that is nothing but confirmation testing or retesting. To log the outcome of the test execution and record the identities and version of the software under test. It's very important to develop logs, test logs. Okay, so what test cases, whenever you execute a test, you have to record the what you have identified, the result, and version of the software under test is nothing but today I can use the version 1 software. Tomorrow I can use it version 2 software. Okay, after making some modification, I may call it as version 2 software. So you have to say that so the test cases which failed in version 1 may pass in version 2. Okay, so now I just want to give the formal definition for test log. Test log is nothing but what are the test cases that are executed. Okay, and suppose if I develop 100 test cases, have you executed or considered all the test cases? So the test cases which we have taken for execution must be there in the test login. In what order we executed, who executed the test cases, what is the status of the test cases. There are two options, either pass or fail. This description documented and called as test log. It is an important question. Okay, you have to be very thorough in test log. To compare actual results with the expected result. During execution, we are comparing the actual result. You know, the test case consists of the expected result. Okay, when you, after getting the result, you have to compare the result, expected result with the actual results. And during execution, where there are difference between actual and expected results, it report discrepancies as incidents. Okay, if there is a difference between the actual results and expected result, that will be recorded. It's all happening during the execution time. And evaluation, exit criteria, and the reporting. It's a part of the software testing. So all these topics we are learning under testing as an engineering activity. Okay, so we are justifying that software testing process is an engineering activity. Okay, so when I say the software testing process is an engineering activity, what I supposed to do it, I have to identify the cyclic process it has. This cyclic process consists of different phases. I'm explaining the phases one by one. Now we are landed at the phase evaluating test criteria and reporting. Exit criteria come into picture when maximum test cases are executed with certain pass percentage. Okay, so in order to conclude, you need not execute all the test cases. So for example, among the 100 test cases you have developed, after 60 test cases, and if some 90%, 80% it is passed, you can leave. You can come to a conclusion that okay, the result would be like that. It is something like getting the poll opinion during the election times. Okay, bug rate falls below certain levels. Okay, so we have to fix a threshold level, and if it falls under, then need not to proceed it when achieve the deadline. Okay, if you achieve the deadline, we can exit the testing. So evaluating exit criteria is the following major task: to check the test logs against the test criteria specified in testing plan to assess if more tests are needed or if the test exit criteria specified should be changed. Then to write a test summary report for stakeholders. Okay, it's all happening during the evaluate test criteria, exit criteria, and the reporting phase. The now final test closure activities. Test closure activities are done when software is delivered. We will see when I can close the testing process. So when all the information has been gathered, which are needed for testing, and when a project is cancelled, or when some target is achieved, when a maintenance release or update is done, so we can close the testing activities. The test closure activities are the following major tasks: to check which planned deliverables are actually delivered and to ensure that all incident reports have been resolved. Okay, so if you get clear confirmation about the developed software is working properly and it met all the requirement of the customer, then we can close our test. To finalize and archive test where such as scripts, test environment, etc. for later use. Okay, once it is over, so we need to, because we are always during the software development environment, we are always insisting on the documentation for the future purpose. Similarly, the scripts which used for the particular test and the environment which used, everything must be archived for the final later use. To hand over the testware to the maintenance organization, they will give support to the software. Okay, the tester's role will end and they will hand it over to the maintenance people. Okay, so if the maintenance people have all these documents, they can solve with the help of the document, they will resolve the future problems. To evaluate how the testing went and learn lessons for future releases and projects. Okay, so it's all learning experience. So each project, each time they will learn some lessons that will be recorded. And what is test axioms? It is impossible to test a program completely, and the software testing is a risk-based exercise. So you are very aware of it. Many times I insisted in the class. That's what I insisted during my initial presentation. If you put 100% effort for software development, you have to put 200% effort for software testing. Okay, testing cannot show that bugs doesn't exist. Testing cannot show that bugs doesn't exist. Okay, there is no guarantee that my software is free from all bugs. Okay, so some bugs will be there. You would have seen in the Colgate advertisement. Okay, so even if you clean it thoroughly, 1 or 2 germs will be there. So it is an indication that 100% is not possible. The more bugs you find, the more bugs there are. Okay, don't be happy that I have identified this much bugs. Okay. It's an indication to you that you have more bugs there. Okay, so not all bugs you find will be fixed. Okay, so don't expect that all the errors or the defects will be fixed. Why I'm saying is sometimes we have to go along with the uh, some defects. Okay, so need not address. So we have to prioritize it. We have to categorize it. Uh, the high, medium risk, high, medium, and low. Okay, so we can address the high and medium and the low risk. We not spend more time. Product specification are never final. It's very important. Don't get disappointed during the development process, because today the customer today the customer will say one and tomorrow they will change the specification, so that it is mentioned product specifications are never final. Okay, can you able to follow me? So I have uploaded 2 videos in the YouTube. Okay. So have you seen the videos? Okay. So kindly opener after this session, go to the YouTube link and watch the video and like the video and give your feedback, comments, because that is the only takeaway from you. Because I recorded and uploaded it the for you people and others, those who are interested to know about the software testing subject. Even today, this lecture is also I'm recording. So you will get the recorded copy also. So whenever you get time, you can go through this and you can revise your subjects. Okay, now let's proceed. So you have to know the basic definitions. I have listed some of the definitions, though we have seen earlier: test basis, test cases, test where, test data, test harness, then confirmation testing or retesting, then test log. Okay, these are all the various definition you are supposed to be very familiar with software as a software tester. Okay, don't study these things for your examination purpose, for your career purpose. You need to know the basic definition for the terminologies. Okay, let's move to the second part. Second part consists of various topics like software testing principles. A tester need to know the various things. I will list it out various things where as a tester you need to know, and the tester's role in a software development organization. Okay, it's quite interesting topic. Let us see one by one. Software testing principles. It provides foundation for developing testing knowledge and acquiring testing skills. What is a principle? Principle is a general or fundamental law, doctrine, or assumption. You have your own principle, I have my own principle. People are living with principles, religions are going with principles. Okay, each party has its own principles. Okay, each family has its own principle. Each um, community has its own principles. Okay, people, we are very familiar with principles. A rule or code of conduct. The laws are fact of nature underlying the working of an artificial device. So similarly, the software testing has its own principles. When you become a software tester, you have to follow those principles. Okay. Principle number one says testing is the process of exercising a software component using a selected set of test cases with the intent of revealing defects and evaluating quality. Okay, I have no other job except identify the defects. Okay, that my entire effort I'm putting in software testing is to identify defects and evaluating quality in the same time, ensuring the quality. Okay, I'm assuring the quality of the software. Okay, so as a software first principle, saying that we have to identify defects and ensure the quality. Second principle says when the test objective is to detect defects, then the good test case is one that has high probability of revealing undetected defects. Very interesting. Okay, I told you software test cases are the test cases playing vital role in the software testing. Okay, when I say that the test objective is to detect defects, the test case has the ability to identify more number of defects. So why I'm saying that when you develop test cases, you must be very careful of generating test cases which helps you to identify various defects. Principle 3 says test results should be inspected meticulously. Once the test is executed, you have to meticulously inspect the result. Principle 4 says a test case must contain the expected output or result. Okay, so if the output or expected result or the expected output or the result is missing, then it is incomplete test cases. Okay, so a test case must be a complete test case that should consist of expected outcome, output or result. Principle 5, Test cases should be developed for both valid and invalid input conditions. Okay, so say for example, when you develop a login credential login system. Okay, so you may fix that the 8 characters, alphanumeric, some of the criteria you can put. So when you test it, you have to test it for the positive value and negative value. Okay, so the simple example I can give, you may develop a software, the user interface may accept the age. So normally any human being very thorough that when they enter the data, they will enter some numeric value. Okay. Sometimes it may happen that instead of numeric value, somebody may type alpha value, alpha numeric value. So what will happen? So when you test, okay, so you have to test it with the help of positive value and negative value. The probability of existing additional defects in a software component is proportional to the number of defects already detected in that component. The probability of existence of additional defects in a software component is proportional to the number of defects already detected in that component. Okay, so that's what I'm saying, that don't be happy that you have identified this much of defects. Okay, it's a clear indication that you have identified 100 defects and there are 100 more defects are there. Okay, so don't be happy that you have to put more effort. Maybe it may be identified in the next iteration. Principle 7 says that testing should be carried out by a group that is independent of the development group. Okay, it is very common at our home. Okay, when our mother cooks food for us, and who will taste it and who will be the good judge? Mother cannot be the good judge for uh, giving good feedback. Okay, we are sitting at the dining hall enjoying the food and we will give the feedback. Similarly, one who developed the software, and when you were during the testing time, should be carried out by the group that is independent of the development team. Okay, in other words, I can say that if you involve testing people, they will give a lot of justification for the development. They will not accept their mistakes. Okay, so testers are independent from the development group. Principle 8 says tests must be repeatable and reusable. Okay, all the test cases, all the test wires, all the architecture, environment, and we can make a number of repeated process, and all these test cases, test wires are reusable. And why I'm saying that, you have to develop, you have to keep in mind when you develop your test cases, when you set up your architecture, when you set up your environment, all these principles should come to your mind, that it is not only for this particular task, it can be used for a number of times by a number of people uh, in the organization. Next, principle 9 says that testing should be planned. I have said more thing about testing, planning, how planning is important for testing. And principle 10 says testing activities should be integrated into the software life cycle. Okay, testing activities should be integrated into the software life cycle. So it is not a single activity. It is not a single process. It consists of various activities, and it has to testing has be there in each and every phase of software development life cycle. So for example, the first phase, software requirement specification, I have to test the requirements which I have gathered. During the analysis phase, I have test analysis, I have designed the test. So it has to travel starting from the requirement specification phase to deployment or maintenance phase. Then the 11th, the final principle is testing is a creative and a challenging task. It is challenging task and it is creative. Your creativeness will be reflected in while you develop your test cases. Okay, it's a challenging task. That's why I encourage you to put 200% effort for your testing phase. Okay, so we have seen 11 different principles. It's an important question. You have to be ready for answering it. And as a tester, what I need to know? A tester needs to have comprehensive knowledge of the software engineering discipline. Okay. So sometimes some people will jump from software industry from other streams they by studying a software testing subject or by studying some software testing tools. Okay, so what basically is encouraged for a tester to have comprehensive knowledge of the software engineering discipline. Software engineering will teach you all 7 phases of software development life cycle. If you want to survey in the industry, you have to be very familiar with the concepts of software development life cycle. That is nothing but software engineering. One who doesn't have the knowledge about software engineering cannot survive in the software industry. That is my strong belief. That is why I always encourage people to go through the concept of, be familiar with the concept of software engineering if you want to shine in the software industry. You have to know the concepts, you have to know the definitions, you have to know the processes of various software development process. So it is encouraged that all the software testers are encouraged to have comprehensive knowledge of software engineering disciplines and have knowledge from both experience and education as to how software is specified, designed, and developed. You need to have book knowledge, you need to have practical knowledge. Okay, so don't say that I will I will be a good programmer. Um, so without theory, you cannot do anything. Okay, you have to be very familiar with the theory part and the practical part. And a software tester be able to manage many details, have knowledge of fault types and where faults of certain type might occur in code constructs. Okay, so while testing, you may have to guess that this particular defects or faults would occur from this particular portion of the code. Okay, then reason like scientist. You have to reason like scientist and propose hypotheses that relate to presence of specific types of defects. A tester needs to have good grasp of problem domain of the software that he or she is testing. Uh, to create and document test cases, design and record test procedures for running the tests, plan for testing and allocate the process resources, execute the test and is responsible for recording results. Don't forget to record the result because even this presentation I'm recording it for the future use. Okay, so whatever you do, you have to record it. Okay, we are very poor in recording certain things. We do everything, we will not record it. Okay, so we have to record it, we have to document it for the future generation. So analyze test results and decide on success or failure for a test. Then a tester needs to learn to use tools and keep abreast of the newest test tools advances. Okay, a lot of tools are coming every day in the market, so we have to be familiar with the latest tools. There's a lot of advantages, so we have to use those tools and work and cooperate with the requirement engineers, designers, and developers, clients, and users. Okay, I just want to stress more on this particular topic that work and cooperate with requirement engineers, designers, developers, clients, users. Why? Because software testing, you have to test your process from the first phase of the software development life cycle. Requirement engineers, you have proper understanding with the requirement engineer. You have to proper understand with the designers, developers, because defects may occur at requirement phase, design phase. Suppose if the defects are not identified at the requirement phase, with the defects it will pass to the analysis team. And if it is not identified there, if it's not tested there, it will be passed with the design, code, finally it will come to you. So you have to put more effort on. So in order to avoid those things, you need to have proper coordination with all the team members. A tester need to be educated and trained in this specialized area. Okay, so if you have all those qualities, and you can be a good tester. If you want to be a good tester, and if you want to shine in the testing field, you need to have all these qualities and requirements or education with respect to education and with respect to your cooperation with your team members. And the tester's role in software development organization. Who is the tester? What is role in the software development organization? It's very important. A test specialist is one whose education is based on the principles, practices, and process that constitute the software engineering discipline and whose specific focus is on one area of the disciplines, that is software testing. Okay, so he must be very specialist on it. We don't simply call them as a software tester, they are the test specialist. A test specialist who is trained as an engineer should have the knowledge on the following: test related principles, processes, measurements, standards, plans, tools, and methods, how to apply them to the testing task. Lot of principles are there. You need a lot of processes are there, measures are, metrics are there, standards are there, tools are there, strategies are there. Okay, you have to be very familiar. So you are if you are very familiar in that, you'll be called as test specialist. Okay. Tester's role in software development organization. Tester is to work with developers to produce high quality software. That means that customers' requirements, then requirement engineers. Okay, so here I am emphasizing the testing, how the software tester have to cooperate with other team members. Okay, tester is to work with the developers. Why the tester has to work with the developers or the coders to produce high quality software that meets the customer's requirement. And as a tester, you need to work with the requirement engineer to ensure that requirements are testable and to plan for system and acceptance test. And the tester need to work the designer. Why? To plan for integration and unit test. The tester has to work with test manager. Will need to cooperate. The cooperation is very important. And the project manager cooperation is very important for reasonable test plans. And they have to have a good relationship with upper management to provide input for the development and maintenance of organizational testing standards, policies, and goals. Testers also need to cooperate with software quality assurance staff and software engineering process group members, because the entire process, the effort you are doing with respect to software testing is to ensure the quality of the product. Okay, they need to have proper understanding with the people those are working in software quality assurance team and other software engineering process group members. Okay, now let's move on to the third part 3. Okay, so hope if you have any doubt, you can interact with me now. Is it audible? It is okay. Can you able to follow me, students? Okay, we have few minutes, and we'll go through the next. So I just want to cover today's objectives to cover Unit 1, and I will give you the recorded video also. If you go through it, you can definitely able to address all the questions with respect to Unit 1. There is no doubt at all. Okay, let's move to part 3. So it consists of origin of defects, defect classes. I will explain with the coin problem case study, then defect repository, defect prevention strategy. Okay, so if you take origin of defects, where these defects comes from. Okay, so what is the origin of these defects? You must have thorough knowledge on it. Lack of education, poor communication, oversight, transcription, immature process leads to defects. Okay, what the impact on software artifacts? It may leads to errors, failures, and faults. Okay, what impact it makes at user side? Poor quality software and user dissatisfaction. If you develop poor quality or the users are not satisfied, your business will vanish. And now we'll see various classes, defect classes and defect repository. Defect classes, requirements and specification defects, design defects, coding defects, and testing defects. Okay, so we have a list of defects with respect to requirement and specification defects. Natural language representation. So requirement and specification. Requirement, the software requirement specification is a document. Document written with the help of a natural language. Okay, when you convert the ideas of your client or the interaction which we had during the requirement elicitation process, okay, when you convert it into a document, it leads to ambiguous, contradictory, unclear, redundant, and imprecise requirements. Okay, so these are all the challenges in front of the requirement engineers, in front of us. So the defects with respect to these problems are listed out under requirement specification defects. Functional description defects. To the overall description of what the product does and how it should behave is incorrect, ambiguous, uh, or incomplete. When it is not defined properly, it leads to functional description defect. And failure defects are due to the failure feature defect features not properly or missing, incorrect, or incomplete. I can give an example. So when you develop a banking application, once the 1,000 rupees, say for example, I'm withdrawing 1,000 rupees. Okay, the machine will dispense 1,000 rupees. The next action is it has to be reduced. The 1,000 rupees must be reduced from the database. Okay, dispensing 1,000 rupees alone is not the future. At the same time, without our knowledge, okay, it is what is happening. It triggers the database, and the 1,000 rupees will be detected in the database. Okay, so if it is missing while communicating or while documenting it in the requirement specification phase, that will be named as future defects. Then future interaction defects, incorrect description of how the future should interact. Then interface description defects, how the target software is to interface with external software, hardware, or users. The design defects occur when system components, interaction with the system components, interaction with the components and outside software, hardware, or users are incorrectly designed. So the various types of design defects are algorithmic and processing defects, control logic and sequence defects, then data defects, module interface description defects, functional description defects, external interface description defects. Then we will see various coding defects. Coding defects are derived from errors in implementing code. So similar to the design defects, in addition that we have typographical defects. You would have experienced several times during your laboratory. A small missing, a small semicolon, missing of semicolon will lead to a number of defects. Okay, that is called typographical defects. Initialization defects. Initialization, the variables are not initialized properly, then it leads to initialization defect. So other defects are part of the design defects. Testing defects, defects are not conformed to code and its related test plan, test cases, test harness, test procedures can also contain defects. Okay, and the defects, so that's what even the test case must be tested. Test harness, the environment, the framework, the package must be tested thoroughly before going for test execution. And defects in test plans are best detected during the review techniques. I can give an example, this coin problem, defects coin problem. So this is an initialization. So there are three variables we are going to use in the coin problem: number of coins, the number of dollars, and number of cents. Okay. So this number of coins, there's a precondition. A precondition is a condition that must be true in order for a software component to operate properly. Okay. Number of coins before it starts accepting the coins, it must be greater than or equal to 0. And post condition is once the values are calculated, after calculating the value, since it is clearly say that it is greater than or equal to 0, it must have some value. So we have to initialize this post condition, number of dollars and number of cents greater than or equal to 0. Okay, this is a case study for the coin problem. Okay, this calculates the total dollars and cents value for a set of coins. Okay, I have identified 6 different denominations: pennies, nickels, dimes, quarters, half quarters, and dollars are 6 various denomination I give as input, and it has a count, and the output would be the dollar and the cent. So here it is all declared. The variables are declared here. Number of coins is an integer value. Number of dollars is an integer value. Number of cents is an integer value. This number of coins, 6 different denomination I have to get, and the output would be the number of dollars and the number of cents. Here is the problem. The program is given. So let us see the various defects it consists of. Okay. So here if you go to this functional defect, we go to the functional defect, unambiguous and incomplete input and output values cannot be 0. Okay, here it is initialized is as 0. Okay, so it's a pre-condition and post-condition state. It must be greater than or equal to 0. So these defects are called functional description defect. The next defect, interface description about how the user interact with the program to provide input and how the output are reported. Here the problem, we made the problem mistake, so it is all coming under the interface. And then control logic and sequence program, we have made mistakes in the while loop. The defect in this subclass arise from an incorrect while loop condition should be less than or equal to 6. Okay, so otherwise it necessarily go for one more looping. And data defects here, the data which is given is wrong. Okay, so I told you, no, 6 different denomination I'm getting. Pennies, nickels, dimes, quarters, half dollars, and dollars. Okay, one cent is called a penny, and 5 cent is called nickels, and 10 cents is dimes, and 50. Here, after 25 quarters, half dollars is 50. So instead of 50, it is given 25. So it is coming under data defects. And data flow defects. The variable total coin value is not initialized. It is used before it is defined. So developer or tester support for developing a defect repository. Defect repository is very important. Once the test results are identified, it must be recorded. A requirement for repository development should be a part of the testing or debugging policy statement, and it begins with development of the defect classification schemes, and then initiate the collection defects data from organizational projects. Then forms and templates will need to be designed to collect the data. Okay, it is a responsibility of the tester to have proper forms and templates to design to collect the data, and recording each defect after testing, and also recording the frequency of occurrence of each of the defects type. And the defect monitoring should continue for each ongoing project. And defect prevention strategy. So prevention is better to help reduce the cost of developing and maintaining software by reducing the number of defects, and require more attention in both review and execution based testing. Help to improve software quality. So if you prevent defects, it helps the quality of the software, improve the quality of the software, could increase the effectiveness of our testing process, and provide a framework for overall process improvement activities. Okay, so encourage interaction, a diverse number of staff. Many times I have emphasized this, project managers, the tester has to have proper coordination with. It's all possible. If you want to prevent and if you want to save the cost, the tester, as a tester, you need to have good coordination with various people like project manager, developers, testers, software quality assurance staff. A close interrelationship between specialized group activities and quality internal and external deliverables. Okay, so definitely you can prevent the things. An organization also must have managerial commitment to successfully implement the defect prevention program. Okay, so defect prevention, if you adopt a defect prevention program strategies, then a lot of things you can avoid. Management must provide leadership resources and support cultural changes. An additional precondition is an existence of a defect repository and a defect reporting system. You cannot prevent defects if you do not consistently classify, count, and record them as they occur. In this way, you know the exit, where and when they occur, and their frequency of occurrence. Okay, so with this, I just want to conclude today's presentation, and hope I would have got more insights. Again, I request all the students, please visit my YouTube channel and subscribe the channel, like it, and give your feedback. I don't want any feedback here now. I want your feedback in the YouTube channel, so that many will view it and it will be there forever. Okay, thank you so much for being with us. Wish you all the best for the next class. Thank you.
Thank you, sir.
God bless you.
Thank you, sir.
Bye. You can close it. You can leave the class and go to the next class. Thank you.
Jerusalem College of Engineering, an autonomous institution located in the heart of Chennai city, the best engineering college in Chennai, NAC A grade accredited and NBA accredited institution, counseling code 1307. Join at JCE to equip and explore to be industry ready.